Welcome to this explainer. Today we're taking a journey that goes way, way beyond the short blip of human history. We're zooming out, past the borders drawn by ancient kings and modern states, to look at the absolute grand, timeless scale of our planet. We're going to witness the relentless geological engines that literally build and shatter our world over billions of years. Prepare to see Earth not as some static painting, but as a living, breathing entity. So, take a second and picture that globe sitting in your old classroom, or maybe a map you've got pinned to a wall. Now, what if I told you the map you memorized is, well, kind of a lie? What if those rigid boundaries chopping our world into 7 neat little continents are really just a human illusion? An illusion that hides a much grander and honestly far more unified geological reality.
Let's start with a number, 70%. I really want that to sink in for a second. 70% of the entire human population doesn't live scattered equally across some highly fragmented globe. No, they live on just one single continuous landmass. When we strip away all our cultural biases, we're actually left looking at a 6-continent reality. And the absolute titan of this model? It's Eurasia. Geographically and geophysically speaking, Europe and Asia are just one unbroken expanse of rock. This unified supercontinent covers a massive 53 million square kilometers and is home to a staggering 5.6 billion people. When you look at it on this scale, the sheer weight of Eurasia completely dwarfs North America, South America, Africa, Antarctica, and Australia. It's a demographic and geological monolith, plain and simple.
Now you might be thinking about the Ural Mountains. For centuries, we've been taught that this mountain range is the Great Wall separating Europe from Asia. But geologically, that's a purely cultural invention, dating all the way back to the ancient Greeks. There's no dividing ocean there. There's absolutely no separate European tectonic plate. It's just one continuous, massive expanse of crust. To separate Europe from Asia is basically drawing a line in the sand and pretending it's an ocean.
Okay, moving into part 1, the engine of the Earth, uncovering the mechanics of deep time. To really grasp how this massive Eurasian landmass, and frankly the rest of our modern map, came to be, we have to throw human timeframes right out the window. We need to become deep time historians. We're peering miles beneath our feet to uncover the immense, unseen geophysical forces at play. Our planet's outer shell, the lithosphere, isn't just one solid sphere. It's shattered into these massive tectonic plates that carry both the continents and the ocean floors, and they literally float on the asthenosphere, which is this churning, superheated layer of semi-liquid mantle. Driven by intense heat radiating from the Earth's core, these immense slabs of rock are in constant, relentless motion. They're tearing apart and crashing together at the exact same speed your fingernails grow. Crazy, right? And this incredible mechanism drives something profoundly awe-inspiring called the Wilson cycle. Think of it as the planetary heartbeat. It's this recurring, violent process where continents drift apart to open up vast new oceans. And then, inevitably, they're pulled right back together to crash into a single, massive supercontinent. One full pulse of this planetary heartbeat takes between 400 and 440 million years. It is a slow, unstoppable rhythm that dictates the entire architecture of our world. Which brings us to part 2, the ancient supercontinents, echoes from billions of years ago. Knowing about this planetary heartbeat lets us travel backward in time. The continents you know today have actually danced this violent cycle of convergence and destruction many, many times before humans ever existed. Just look at the sheer magnitude of this timeline. Go back 3.6 billion years, and you have the very earliest continental crusts slamming together to form Vaalbara. Fast forward through billions of years of tectonic reshuffling, and by 1.1 billion years ago, the colossal supercontinent Rodinia assembled, creating the ancient cores of what we now call North America and Australia. And then, about 335 million years ago, the cycle climaxed again. Every single landmass on Earth united into one monumental supercontinent, completely surrounded by a single global ocean. They called it Pangaea, literally meaning all lands.
Up next, part 3, the breakup of Pangaea, the violent birth of the modern map. The Wilson cycle demands that whatever comes together absolutely must be torn apart. The destruction of Pangaea was the violent genesis of the borders we know today. The tearing of the Earth's crust kicked off about 200 million years ago. A massive rift violently unzipped Pangaea right down the middle, splitting it into 2 megacontinents, Eurasia up north and Gondwana in the south. As the crust stretched and finally snapped, ocean waters came flooding into the rift, giving birth to the vast South Atlantic Ocean. And then, in what has to be one of the most dramatic geological events in Earth's history, the Indian Plate broke off. It raced northward across the ancient sea and smashed right into the underbelly of Eurasia. That collision was so incredibly powerful, it crumpled the crust and thrust the mighty Himalayas straight into the sky.
So a really crucial point here is how the southern giant, Gondwana, shattered into the pieces we recognize right now. Just think about where everything went. South America ripped away and drifted west. Africa pushed north. Antarctica was essentially exiled, left to freeze at the isolated South Pole. Australia broke off and sailed east. Every single piece was scattered by the currents of the deep mantle. And here's the thing you have to remember. This movement hasn't stopped. The map you're used to looking at, it's just a temporary snapshot. These colossal plates are moving beneath your feet at this very second.
Which leads us to part 4. The cycle continues, a glimpse into the next supercontinent.
Because the engine never sleeps. The oceans we sail today are eventually going to close, and the continents are going to collide once again. The only real question is, what is the Earth going to look like when the cycle completes its next rotation? Geologists have cast their models about 250 million years into the future, and they've come up with 4 pretty haunting scenarios for our next supercontinent. First, we have Orica, where the continents crash together at the equator, closing both the Atlantic and Pacific Oceans. Then there's Amaja, which is an extreme polar convergence that would completely obliterate the Arctic Ocean. Third is Novo Pangaea, assembling as the Pacific completely collapses. And finally, Pangaea Proxima, where the Atlantic reverses its course, slamming the Americas right back into Africa and Europe to form this massive C-shaped landmass.
Now, no matter which of these models ends up being correct, like the equatorial Eureka, for instance, the reality is a future of severe extremes. When all these landmasses merge into one, moisture from the ocean just won't be able to reach the deep inland areas. We're going to see the birth of harsh, hyper-arid superdeserts spanning thousands of miles across the interior. On top of that, global ocean currents are going to be violently disrupted by having just one unbroken superocean. This will drastically alter planetary temperatures and completely rewrite the rules of habitability on Earth.
Ultimately, we are just passengers on a shifting rock, floating on a sea of molten fire. The tectonic engine is going to keep running long after we're gone, reshaping the continents, opening new oceans, and forging brand new mountains. So, I'll leave you with this awe-inspiring thought to chew on. As you stand on solid ground today, where do you think your piece of the continent is going to drift next?